Alright, this is the Math 2 Unit 10 second semester final review. Kind of going through the next couple of pages here of your worksheets. As we start this one, I want to kind of go over a couple of things real quick right at the start just to recall. If we multiply exponents that have, or numbers that have exponents with the same base, so I have the base A and the base A, and we're multiplying those together. Recall that what that means we're going to do is we're going to add the exponents together. So we end up with, if it's a to the third times a squared, that becomes a to the fifth. Now that's different from if we have a to the third and we take that and we square it. When I have a exponent raised to another exponential power, that becomes a to the 3 times 2, which is a to the 6. So again, this works if we have the same bases. If I multiply the same bases, then I add exponents. If I have something to an exponential power, then I multiply. So I always talked about it being something like when I multiply, then I go down a level. Instead of multiplying, I go add. And if I exponent, to go down a level, I'm going to multiply. Also keep in mind that when we have exponents, we don't want to have a negative exponent. So if I was to have a negative, or 8 to the negative 2, that becomes 1 over a squared. If I have a 1 over a to the third, or a to the negative third, sorry, I don't want to leave a negative exponent in the denominator, so that becomes a to the third power. And it's good just to rewrite those when you see them, so you just get in the habit of rewriting those. So that's some basic things there as we go through this. One more basic thing here just to keep in mind is that when we start looking at radicals, if I have x to the 2/3 power, okay, if I have x to the 2/3 power, that means that this becomes the radical here, and this becomes the exponential value. So this would become, if I rewrote this, this would become 3 root x squared when I rewrite that. So you want to be able to go back and forth between the two forms here. X to the 2/3 becomes root 3x squared. So be comfortable doing that. If I was to have something where I had, for example, let's say I had x to the 2/3 again, and that whole thing was raised to the 1/4 power. This becomes x to the 2/3. I can stay underneath the radical, and then this becomes a root 4. So what happens is this exponent here becomes the root 4. Now, there is a 1 there. If I wanted to think about it, I could have that all to the first power, and that's where the 1 went away to. So that 1/4 became 1/4. So just keep that in mind as we go through this, so that we have a few of these as we go along. So here we go. Let's look at number 1a. So simplify with no negative exponents to begin here. What I like to do is rewrite this first, and then I reduce. So my first rewriting, I'm going to go ahead and say x squared can stay there. That's no problem. This y to the negative 4 needs to drop below because it's a negative, so I'm going to move it down. When I look at the denominator, x to the minus 3 needs to go up top, so that becomes x to the 3rd. And y to the negative 6 goes up top, and I get y to the 6th. From there, what I look at is I have the same bases, and when I have the same bases, I'm multiplying something with the same base, then I take 2 and I add it to the 3. So 2 plus 3 is x to the 5th power. Okay. Now looking here, I have y to the 6th over y to the 4th. So what I want to do is do 6 minus 4 becomes y squared. And actually when I end up here, I don't have anything in the denominator. I leave it just like that. X to the 5th, y squared. Okay. On the next one, be careful here because we are going to use distributive property, and we're going to multiply because I have this term times that term times a b, but pay attention, be careful, don't catch the small things. This middle term is cubed. So the first thing I actually need to do is I need to cube this middle section. So what I'm going to do is I'm going to cube each part. So negative 2 cubed becomes a negative 8, because 2 times 2 times 2. A times a cube becomes a cubed. And again, if I have an exponent raised to an exponential power, I'm going to multiply. So the b becomes negative 2 times 3, or negative 6. So that's how I rewrite that middle term. Now I'm going to go ahead and bring down my b value there, and my a to the third, b to the negative 7 value there. All of these, of course, are all simply multiplied together. Okay, so I have a to the third times b to the negative 7 times negative 8 times a to the third times b to the negative 6 times a b. So now what I want to do is basically combine things that match. I'm going to pull out my whole number first, negative 8, no problem right there. Now when I look at my a's, I have, because of the base is the same, a, right? I have a 3 plus a 3 gives me 6, so a to the 6. And for my b's, I have b to the negative 7 and a negative 6. So negative 7 minus 6 more is negative 13. This is a positive one though, so I end up with b to the negative 12. But I don't want to leave it like that in that form, so I'll rewrite that as negative 8 over 8a to the 6 over b to the 12. So I have no negative exponents. Okay, moving down to number 2. Using the radicals here, we want to write it in the form a b over c. So this becomes, like we mentioned before, x to the 2/3 is what I have inside the parentheses here, and this root 6 is actually 1 to the 6th power. Like we said in our beginning, if I have an exponent raised to exponential power, I'm going to multiply those together. So 2 times 1 is 2, and 3 times 6 is 18, and that of course reduces down to 1 over 9, and I keep my x where it is, so I end up with x to the 1/9 power. For choice B, I have a couple things here. I have 6 to the 1/10 power times 6. I'm going to rewrite this here. The exponent becomes my numerator, and the radical becomes my denominator. Now, because the bases are the same, and I'm multiplying here, when I multiply the same bases, then I add my exponents. So 1/10 plus a 3/5. I'm going to add that up. To add exponents, I need to have a common denominator. I'm going to go ahead and use a 10. So to turn this into something with a base 10, to go from 5 to 10 is a times 2. So 3 times 2 is 6. And now I can go ahead and add 1 plus 6 is 7. And I keep the denominator the same, 10. And my base term stays exactly the same. So I end up with 6 to the 7/10. On the next one here, we have x to the 1/3 squared. And again, this can be rewritten as 1/3 times, and think of it as 2 over 1. And when I'm raising to exponential power, I multiply. And so this becomes x to the 2/3 power. Simple as that. Okay, number 3. We have to simplify these here, which means we've got to do a little bit of work. So we're working backwards this time. This becomes 16. That's my exponent cubed. That's my radical squared. Okay? If you want to think of it this way, you could. This is really 16 times 16 times 16, square root of all of that, right? That's my 16 cubed. And what's the square root of 16? 4, 4, and 4. So I could pull all that out of the radical by making it 4 times 4 times 4, which equals 64. For B, I can rewrite this one as well. This becomes 27 to the 2/3 power. And again, I can look and think to myself, well, which way do I want to go? I would start this way. I would say, well, what number can I take a cube root of? Can I take the cube root of 27? Sure I can. The cube root of 27, right, the cube root of 27 is actually 3. 3 times 3 is 9, times 3 is 27, right? 3 times 3 times 3. So I have a 3 that I can pull out of that, but I still have the squared, so it becomes 3 squared, which equals 9. For choice C, working with a radical, I can turn this into 9 times 2. That multiplies up to get to 18. The square root of 9 is 3, and I can't do anything about the square root of 2, so it just stays what it is. So I have 3 root 2. Number 4. We have root 3, root 7, root 11, root 13. I have to decide true or false. Are all the numbers real numbers? Yes, they are real because those are not imaginary numbers. Are they all rational numbers? The answer here would be false. They are not rational because they go on and on and on and on. They have unending decimals. Are they all the numbers are irrational? For that one, the answer is true. They are all irrational because if you were to use your calculator, you find they just go on forever. And then finally, are they all integers? That's going to be false. And the reason that's false is because an integer is going to be a whole number. And these are going to be decimal numbers, so it's not going to be an integer. Moving on to number 5. Working with radical expressions. They want to leave us in radical form. That's the goal. So, to do this here, we're going to multiply the different parts. First, we multiply the 5 times the negative 2 to end up with a negative 10. Then I multiply the radicals together. So I end up with a radical of 3 and a 7. Nothing I can really do about that. I can't do any square rooting with 3's and 7's. So this just simply becomes 10 root 21. On the next one, similar idea. I'll do negative 5 times 7 to get a negative 35 on the outside. And that becomes the radical, or square root of 12 times 3. Now, this one I notice that 12 can be broken apart into 4 times 3, and I still have this other times 3 right there, with my negative 35 in front. Okay? So if you want to put that back together, I could or not, it doesn't matter. The square root of 4 is 2. So I'm going to go ahead and take the 2 and put it on the outside now, because square root of 4 is 2. But the square root of 3 squared, or 3 times 3, is simply 3. Which means now I have negative 35 times 2 times a 3, which equals a total of negative 210. For the next one, I can do it in parts. First I can do 6 divided by 3, which is 2. And then for a radical 45 divided by radical 5, that becomes something like this, radical 45 divided by 5, which happens to be 9, so 2 root 9, and the square root of 9 is 3, so 2 times 3, which equals 6 for letter C. For number 8, I have just some similar things here, so I can kind of add up like terms basically is what you're doing. I have a whole number 8 and a whole number 5 for 13. And then I have a square root of 3 and another square root of 3. So what I actually have is I have 2 square roots of 3. So think of it a little bit like if I had an A plus an A. A plus A is 2A. This is like root 3. Root 3 becomes 2 of the root 3's. In this one, choice E, just be careful about choice E that you make sure when you're doing choice E that you remember to make this a negative 5 because the negative's there, and a negative times a negative is a positive. Okay, so I'm going to change that around a little bit there. I have minus 5 and plus 2 root 3, 13, sorry. Whole numbers, I have 7 and minus 5, so 7 minus 5 is 2. And then here, the same basic root, root 13. So negative 9 plus 2 is negative 7, and I keep the root 13 as it is. For number 6, we have to solve for x. So we're trying to put it into this fractional exponent type form. So I'm going to turn these around first of all. This becomes 18 That's my exponent, 3. That becomes my denominator, 4, times 18, and I have 6 to the 4th. Alright, because that's there. So they have the same root 4. If I take this because same base and add up 3/4 plus 6/4, that becomes 18 to the 9/4. And all we're looking for is what is that top term? X is going to equal 9. And for choice B, same idea. Here I have 7 1/3, and on the top I have 7 5/12 over 7 1/3. This becomes essentially a fraction subtraction problem. I'm going to do 5/12 minus 1/3. To do that, this needs to be a common denominator, so I make it 12. So to get from 3 to 12, that's times 4. 1 times 4 is 4. So 5 minus 4 is 1 with a base of 12, and our base term is a 7. So I end up with 7 1/12. We want to solve for x, which is right here, so x equals 12. Select all the expressions that are equivalent to this. Alright, let's take a look at this. First thing I want to do is I need to go ahead and distribute the 2/3 to all the other pieces. So 8 to 2/3 is, I can look and think, what number can what's the cube root of 8? I can break 8 into 2, 2, and 2. So the cube root of 8 is 2, and I square it, and I end up with 4. So my whole number becomes 4. This part, though, I'm going to multiply 2 times 2/3 and end up with 4/3. So this becomes x to the 4/3 power. So one way of rewriting this, first of all, is right here. Now let's take a look at what I have, my choices. First I have 8x squared, which is that part, and I have cube root and the whole thing squared. We said before, this becomes our radical, and this becomes our exponent. And that's exactly what they did there. There's my exponent, and there's my radical. So A is certainly a choice. When I look at B, I have 8x. I don't have the squared anymore. It went away, but I still have that. You can see what they're trying to do is to say, well, if you put those together, you get 4. Well, that's true, but if you were to distribute that square, it has to also go to the 18. That one did not do it. So that's not a choice. Over here, we have 4x and then x to the cube root of x power, or cube root of x. That one's actually going to be okay, and here's why. If I look here at my first solution, right here, 4x to the 4x power, this can become 4, and if this is the cube root of x to the 4th, that is x, 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 x. Okay, that's 4 x's. So the cube root says, do you have a group of 3? Sure, there's one group of 3. So I can pull that group out, but I still, under the cube root, have 1 x remaining. So there I am, and that's how that one is going to be okay. For choice D, they just simply put the 4 in the front, and they rewrote x to the 4/3 as cube root of x to the 4th. So that is also okay. And this last one here, they got rid of lots of things, and so this one's actually not okay. Let's look at the next side. On the back side here, more radicals, we're going to select an expression that is equivalent to those. So to do this, what I went ahead and did is I said, well, this is actually 2x squared to the 1/4 power times 2x cubed to the 1/4 power. Okay. So then I broke this apart and I said, well, let me distribute the 1/4 throughout. So this became 2 to the 1/4 times 2 times 1/4 is x to the 2/4. I'm just going to leave it like that for now. Okay, and over here I have distribute the 1/4, so this is 2 to the 1/4 times x to the 3/4. Now I have some similar bases, 2 and 2, so that means if I have similar bases, I add exponents. 2 and 1/4, a 1/4 plus a 1/4 is a half, or I could look at it this way, it's actually 2 and 2/4 because 1 plus 1 is 2. And that's going to be multiplied by x, same base, a 2/4 plus a 3/4 is a 5/4. And that's where I'm going to stop at right there because that matches choice B. Okay, so I have to rewrite the radical as an exponent and then distribute the exponent amongst each part. So make sure you do that for each one of the parts there. Number 9, select the equivalent expression to that one there. Alright, no problem. So I have 1/3 x to the 1/4 times 1/3 x to the 2/3. Okay, so the thirds, I can go ahead and multiply those together on their own. So 1/3 times 1/3 is 1/9. Now for the exponents, I have x to the 4th times x to the 2/3. And when I'm doing that, I'm going to add. So a 1/4 plus a 2/3, common denominator would be a 12. 12. To go from 4 to 3, that's 4 to 12, that's times 3. 1 times 3 is 3. To go from 3 to 12, that's times 4. So 2 times 4 is 8. So this becomes 3 twelfths plus 8 twelfths, which equals 11 twelfths. Just a fraction problem. But my base term is still x. So I have 1/9 x to the 11 twelfths. Okay, which when I look at my choices here, we have radical form, but only one of them has a 1/9, which is this one so far. I double check this, and this is x to the 11 twelfths. So it still would be choice C for my answer for number 9. On number 10. For number 10, I'm going to have to do a little bit of work on this one. Okay, so I'm going to go ahead and I'm going to, first of all, I'm going to distribute this through these terms here. Alright, so let's rewrite this as 8 1/3 times 8 2/3 plus 8 squared. So 8 1/3 times 8 1/3, I'm going to add those up, and that becomes 8 3/3. Again, same base, I'm multiplying, so I add the exponents. And over here, I'm multiplying, same base, so I add the exponents of this one. But 1/3 plus 2 is basically 2 1/3. If I was to rewrite 2 1/3 as a fraction instead of a mixed number, I do 2 times 3 is 6, plus 1 is 7. So I actually end up with 8 to the 7/3. Okay? So I have 8 to the 3/3 plus 8 to the 7/3. And when I look at my choices here, this becomes 8 to the 3/3 and 8 to the 7/3. So I'm going to go with choice C. Kind of some funky little rewriting there, but that's how that works. Alright, number 11. Select the equivalent fraction. So I'm going to rewrite this here. We have 5 to the 3/8 times 5 to the 2/4. Okay? Again, because the base is the same, I'm going to add these. So 3/8 plus 2/4. Right? If I wrote it down like this, 3/8 plus 2/4. I find a common denominator. I'm going to go with 8. To go from 4 to 8, I multiply by 2. So I do the same as the denominator. 2 times 2 is 4. So 3/8 plus 4/8 is 7/8. And my base number stays the same. So I put 5 7/8, which is choice D. Number 12, it says I want to find two numbers that I multiply together and they're irrational, and when I add them, they are rational. Well, here's what I would use. I would use 2 minus root 7 as 1, and the other number I'd use would be just a plain old root 7. The reason for that is when I multiply it, I still end up with the root 7 all in there. I end up with a radical, and so that's going to be irrational. But when I add them, those two terms here will cancel out, so I'm left with a whole number 2. That's why that one works. When I multiply rational and when I add, it's irrational. So in that case here, I'm going to get 2 irrational numbers, root 7 and maybe 2 root 7. So when I multiply, it makes the radicals disappear, and I put 2 times 7 for 14. When I add them, I end up with basically 3 root 7. So it's still irrational. And then if I want them to multiply irrational and add irrational, I'm going to go ahead and do the same kind of idea. I could do a root 2, just different roots, and a 2 root 7, so they won't combine nicely, and it just stays like that. Number 13, I have to find all the statements that are false for number 13. Well, x minus 2, or sorry, 6 minus 2 is 4, so this actually becomes x to the 4th. So that one's going to be false. In this case here, because I'm exponing it, exponent to an exponential power, this becomes 2 times 4, which becomes y to the 8th. So this one was also false. In this case here, b to the negative 3rd becomes 1 over b to the 3rd power, which is not that right there, so that's also false. On this next one, they want to say that this is equal to that. Well, to find out, I have to distribute that 4 to each part. So 4 times 4 is 16. 4 times 3 is 12. And 4 times 1 is 4. Now I can combine my x's, and I have x 16 plus 4 is 20, and y is still 12. X to the 20th, y to the 12th matches that, so that one is actually true for the very first time. And finally over here, I have to multiply that out. So 4 times the negative 5 becomes b to the negative 20, which looks like 1 over b to the 20th, and does not look like that, so that one was also false. Last section here for this one, simplifying each expression. Here we go. To do this here, I'm going to do 3 times 5 is 15. I'm going to do the square root of 2 times 18. Now the square root here part becomes a 2 times 2 times 9, or written as 4 times 9. And I recognize that the square root of 4 is 2, and the square root of 9 is 3. 15 times 2 is 30, times 3 is 90. For choice B, I have 7 times the square root of 36 is 6. 7 times 6 is 42. The next one, this can become square root of 15 over 3. And 15 divided by 3 is 5, so that's the square root of 5. And this one's going to be an irrational number. It does ask you to label that there, so that's irrational. The other ones were rational. The next one, I have 4 times 27 to the 2/3 power. So the first thing to do is do this 27 to 2/3 power. This happens a lot here. So 3 times 3 times 3, so the cube root of 27 is actually 3. And 3 squared is because there. 4 goes out in front. I keep the 4. And 3 squared is 9, and 4 times 9 is 36. And then our last one. In these numbers here, we have 3 root 2, and then 5 root 18. I'm going to keep that like it is, and then I'm going to break apart the 18 into 2 times 9, and then this becomes, carry this down, 5 times square root of 9 is 3, and I still have a root 2, so 3 root 2 plus 15, I multiply those together, root 2, it's like the same base basically, so I can add up the front terms, and I have 18 root 2, and this is also an irrational number, 18 root 2. Alright, and that is it for the review for Unit 10, second semester. Hope that helps.